Hello students. In the last class we have discussed about the BCD codes and the operators we have discussed in the previous classes, and the gray code to binary and the binary to gray code interconversions we have discussed in previous class. Today's session we have to start with a new digital electronic syllabus. It is a logical gates and the Boolean algebra. This is a very important for your examinations. um, and the first one, a definition of the gate. What is the gate? Is a logical circuit with a one output or a more inputs, one output and one or more inputs, and output signal occurs only for the sustains the combination of the input signals. Means that is that we are giving the many of the inputs. If we are giving the inputs one or more, but the output will be one, the output is only one, that is call it as a logical gate. Logical, why we are using the word, it is the logic. Logic means if you are in the circuit on and off like a switches, it this gates are operated like a switches. Switches means it is in the on state, off state it is a zero. In the on state, we can conduct the electricity through the circuit, it is a high or a low. Which one will you choose? And by the gates, the operations will come, but the gates are the two or one or more inputs, and the only one output can we get it. That is call it as a gates means a logical gates. In the Boolean algebra we have to study it for the some formulas for that one, for this syllabus. Yes, basic logic gates and the universal logic gates can be divided into the two groups. In the logic gates, the logic gates are what are OR gates, NOR gates, NOT gates, NAND gates, and gates. These are the types of the gates. These are the types of the gates. The basic gates, what we have to discuss right there. In this unit, we have to discuss about the Boolean algebra, fundamental concept of the basic laws of the Boolean algebra, Boolean function and minimization, logic gates, logic circuits and the Boolean expressions, combination of the circuit and the design we can discuss about in this the whole unit we have to discuss about this one, right. Then we have to discuss about the Boolean algebra and Boolean algebra that deals with the binary numbers. Anything it is in the logical gates and in the digital electronics, we have to discuss about the binary numbers. It the whole digital electronics, it depends on the binary numbers. The George Boolean in 1815 and 1864, an English mathematician, developed it for simplify the representation, manipulation, propositional logic. In 1938, Claude E. Shannon proposed the using Boolean algebra in design or relay switching circuit. Relay switching circuit means if your switch is on and the switch is off, can we use it? If it is in the off, can we use it as a zero? Can we it is on? Can we use it as a high? Can we use it in the symbolic representation? Will be the different, like a lamp, can we take it, right? uh, in 1938, Claude Shannon proposed using the Boolean algebra in design of the relay switching circuits, providing the economical and the straightforward approach used extensively in designing the electronic circuit used in the computers. This is the logic gates. You can the computer will understand only a binary numbers. That's why this logical expression can be used in the computers. Fundamental concept of the Boolean algebra: use of the binary digit. The whole concept of the digital electronics, it depends on the binary digits. The Boolean equation can have the either the two possible values, 0 or 1. There are the two possible values are there. ಎರಡು possible values ಇರೋದಂತಂದ್ರೆ ಒಂದು 0 ಇಲ್ಲಾಂದ್ರೆ 1. The logical addition. The logical addition you have studied. The addition and the subtraction of the binary you have studied. But we can give it the operator name. Can we give it the operator name? It is a different it here. The logical addition, can we call it? The symbol is addition symbol, also known as a OR gate. We can call it as a OR operator. OR operator using the for the logical addition follows law of the binary addition. The law of the binary addition in the previous session we have discussed. The logical multiplication is a AND operation. The AND operation of the logical multiplication, we can use it as AND operations. Used for the logical multiplication follows law of the binary multiplication. The complementation. The complementation of the symbol, we can call it as a subtraction sign. It is a subtraction. It is a subtraction sign means also it is a complement means it is an inverse law. Inverter, like an inverter, can we use it like a NOT gate? NOT gate for the complementation follows laws of binary complement. We cannot use for the subtraction, it is used for the complement sign, right? The operator precedence. Each operator has a precedence level. First, operator precedence means what? Operator precedence means we have to understand the what is the operator will operate, the performance of the gates, can we use it? Each operator has a precedence level. Higher the operator's precedence level, earlier it is evaluated. Expression is scanned for the left to right. The first expression enclosed within the parent, parentheses are evaluated. Then all complement not operations are performed. Then all AND operators are performed. Finally, the OR operators are performed. Like in your 8th standard, 9th standard, you have studied about this precedence. Like a Bodmer's rule. Like a Bodmer's rule. Have you studied? Bracket first, right? Of division, multiplication, addition, subtraction. You have studied about this Bodmer's rule. We have to study it here also. We have to apply for this Bodmer's rule. For example, it is first one is a OR gate is there. Then and which one will not are there? Which one will you in the mathematical operations will come? Which one will you first solve that one? This is a the operation of the follows in this way for that one. Operator precedence. Higher operation precedence earlier first. Higher operations means, for example, in the Bodmer's rule, bracket is the first one. Of, then afterwards division, multiplication, then addition, and then you have to subtract a value. At the same thing, you have to read that one. For example, I am going to take that one. 6 into 8 plus 5 minus 3, it is there. Which one will you take that one first? Which one will you take that one? This bracket we have to solve it first. This bracket will be solved it first. Right. What we have to do that one? 6 8s are 48 plus 5 minus 3. What will you do that? Addition. Yes, 53 minus 3, 50 will come. Like that, we have to do the Bodmer's rule apply for that one. At the same way, we have to perform this one by the mathematical operations. We have to write this precedence way. Operator precedence. In this way, we have to solve this gates. Next, this is a precedence. First one is a not, first precedence. Second precedence is a multiplication. Third precedence is a whole equation. For example, this is the same way I'm going to give us some example. 5 plus uh, hmm, 5 into 5. Can we take it? First multiplication, can we use it for the Bodmer's rule? 25 plus 5, it's a 30. At the same way, in the logical operation, NOT gate is a first precedence, then is a AND gate, then is a OR gate. That is a importance we can give that one. You will get to know that one. What is a OR gate? What is a NOT gate? What is the operation of the NOT gate? Let us see that one. Yes, this is the precedence operation of the logic gates. Which one will be the first preference? Precedence means it is a preference. Which one will be the first preference? Can we see it? Like, next, the postulates of the Boolean algebra. Postulates of the Boolean algebra. If the postulate number 1, right, a equals to 0. If and only if a is not equal to 1, means if a equal to 0 is there, if it is this successful, if it is a is not equal to 1, if it is, if the condition of the a equals to 0, if this condition is successful, obviously a is not equal to 0. A is not equals to 0. If the condition is a equals to 1, obviously this condition will successful, the a is not equals to 0. A is not a 0, a is a 1. If a is a 0, a is not a 1. Not a 1. This is the first condition of the expressions. Postulate number 2. If the condition is x plus 0 equals to x, whether x is equals to 0 or x is equals to 1, anything, 1 plus 1 is also a 1, 1 plus 0 is also a, sorry, yes, I am going to take that one. Here in this condition, postulate number 2, this is the x equals to 1. 1 plus 0 is only the x will come. 1 into 1 only a come 1. That's why this x equals to 1. We have to think it. These kinds of multiple choice, they will come that one. Now what is the answer of, what is, they will give these conditions, what is the value of the x? X is a 1. Commutative law. Commutative law is x plus y equals to y plus x. This is a condition. You have to study it. Right? X plus y equals to y plus x. Wherever you can take that one, you have to operate. X into y equals to y into x. And you have to know about this one. Xy equals to yx. X plus y equals to y plus x. This is a condition of the commutative law. And they may ask for your examination which one is a commutative law. For example, 1, 2, 3. They will give that one. X, z into y, x into zy. Third, fourth one is a none. They will give that one. Which one is a fourth condition will be that they will give that one A and B. Which one will you the answer? The answer is A and B. These kinds of multiple choice questions they may ask for your examinations, right? Postulate number 4, associative law. X plus y plus z. This is what I have given that one in the multiple choice questions. That was the associative law. Only two laws of the commutative law. Correct. X plus y plus z equals to x plus y plus z. These expressions are very important for to remember for your examinations. This is all laws are very important to remember. Yes, these are the very important for your examinations. X plus y plus z equals to x plus y plus z, right? This is the equation for that one. For example, if you solve that one, x plus y plus z equals to x plus y plus z. But if your equation is like that, this is a explanation is like that. If your expression is like that, the if your first precedence is this one, second precedence is this one, here the first precedence is this one, second precedence is importance is that one. Yes, keep it in your mind. X into y into z, first is a bracket, then afterwards is a or operations and operations. Postulative 5 is a distributive law. X into y plus z equals to x into y plus x into z. You have to do that one. X into y plus z multiply x into y plus x into z. This is the equation comes here like x plus y into z. What it comes? This is the expressions. X into y, otherwise x plus y multiply x plus z. This is an expression can be used like that. Postulate number 6, x plus x bar equals to 1. Why? Whether the x equals to 1, yes, 1, x plus x bar is 0, x is a 0, x bar is 1. It is always comes to 1. It is always comes to 1. X into x bar is always comes to 0. Yes, x is equals to Yes, I'm just explaining that one. X equals to 0. X bar is always 1. 0 plus 1, 1. X equals to 1. X bar equals to 0. 1 plus 0 equals to 1. This is the way we have to express for the uh, these expressions. X into 0, 1 into 0, 0 into 1. It is always a 0. This is the expressions. They will come for your postulate number 6. Next we have to discuss about the logic gates. Logic gates, can we express it? Then afterwards we have to discuss about the operations of the Boolean expressions, right? In the gates, you have to study about the Boolean postulates. We have to solve this using these postulates. We have to solve the bigger expression into the smaller expressions, and smaller expressions into the bigger expressions. We have to study about this one. First one is the expressions they have given like that. Principle of the duality. Duality means precises the duality between the operators and the or operations. The digits are 0 and 1. The, for example, table below, second row is obtained from the first row, vice versa. Simply interchanging the OR gate with the zeros and 1. It is a column number 1. It can express 1 plus 1 is a 1. 1 plus 0 is a 1 plus 0, and the 0 plus 1 is equals to 1. 0 plus 0 equals to 3. In the or and operations, 0 into 0, 0, 0 1, and the 1 0 is equals to 0, 1 1 equals to 1. This is the and operations, right? Therefore the particular theorems to provide the dual theorem automatically holds the need of the provided separately. The some important theorems of the Boolean algebra. X plus x equals to x into x equals to 1. Independent law. This is called it as a independent law. X plus 1 equals to 1. X into 0 equals to 0. I have told you. Yes? X plus x equals to x, it is the both x are means x is always equals to a 1. In this expression it is a x equals to 1. Yes, 1 plus 1 equals to 1 will come. Yes, 1 into 1 equals to 1 will come. Otherwise 0 plus 0 will come. The answer will be the x will come. X into 0 equals to 0 will come. The answer will be the x will come. That is the theorem of this one. X plus 1 equals to 1. X equals to 0 or a 1, whatever it comes is here. It is a always 1. 0, 1, whatever comes. X equals to 0 or x equals to 1. Whatever will come. 0 is there. 0 plus 1 is a 1. X equals to 1 will come. 1 plus 1 equals to 1. And again same. X is a 0 into 0. 0. 1 into 0 is a 0. In this way we have to prove for these expressions. X plus x into y equals to x. X into x plus y equals to x. That is a absorption law. X double bar equals to x. X double bar is always equals to 1. X equals to x is double bar equals to x. This is a very important for your to solve the equations very easily. That is a involution law. X into x bar plus y equals to x into y means, what I am telling is, x into x bar plus y equals to x into y is the answer. X into x bar, what it comes, we have to discuss. Yes, x plus y equals to x into y will come. X plus x bar into y, we can use it as a x plus y. This is a expression can be used it like that. X plus x bar equals to x bar into y. This is an expression. Can we use it x plus y? This is a very important law for the to solve the expressions. X plus x whole bar equals to x bar into y bar. This is a De Morgan's equations. There are the two laws are there. X plus x bar equals to x bar into x y bar. X plus x into y bar equals to x. It is a equation is wrong is here. X into y whole bar equals to x bar plus y bar. This is a De Morgan's law. It is a separate, we have to discuss about the De Morgan's laws. Methods of providing the theorems. By using the postulates of the show that the LHS equals to RHS. Left hand side equals to the right hand side. By perfect induction of the exhaustive of the emulation enumeration method, where all the possible combination of variables involved in the LHS and the RHS are checked. Eld. In the previous, you were discussing about the theorems. If you want to provide for that one, if you need for to uh, write this things, all those things. But in this year, you have to write for the multiple choice questions. LHS and the RHS sides expressions, you have to less concentrate on that one. Why? Because I am telling that one. For example, if you have a multiple choice questions, you have to get the answers, direct answers. You have to notice that one. That's why I'm telling this one is the expressions are important. In the LHS, they will give that. RHS, you have to find it. That will give that one. No need of the satisfaction of the answers will not expect for that one. By the principle of duality, the dual of an already proved theorem is derived from the proof of its corresponding pair. First one, x plus x into y equals to what they will ask for your exams. Here you have to prove the x here. What will come for your multiple choice questions? It's a proof it is there. How can it comes? X is a common, 1 plus y it is there. I want to ask you one thing. 1 plus x, what they have given that? 1. By the invention laws, right? This is a x instead of y, 1 will come. This is a x. ಇನ್ ಯಾರ ಇನ್ ಮೊದಲಿಗೆಲ್ಲ ಹೆಂಗೆ ಕೇಳ್ತಾ ಇದ್ರು ಅಂತಂತಂದರೆ LHS = RHS ಪ್ರೂವ್ ಮಾಡಿರಿ ಅಂತ ಕೇಳ್ತಾ ಇದ್ರು. ಬಟ್ ಇವಾಗ ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸ್ ಕ್ವಶನ್ಸ್ ಬಂದಿರೋದ್ರಿಂದ ಯಾವ ರೀತಿಯಾದ ಕ್ವಶನ್ಸ್ಗಳನ್ನು ಕೇಳ್ತಾರೆ ಅಂತಂದರೆ ಎಕ್ಸ್ ದ ಆನ್ಸರ್ this answer will not expect for that one. This means x plus x into y they will give that one. What is the answers? You have to solve it. X is a common for both the sides. 1 plus y. You have studied 1 plus x. 1. X equals to 0. 1. X equals to 1. 1. That is a 1. X into 1 equals to x. You have to, your answer is, the options they will give that one. What is that? Option A, x. Option B, y. Option C, xy. Option D, x plus y. They will give that answer is x. If you are expecting that these kinds of answers at right now, ನಿಮ್ಗೆ ಈಗ ಯಾವ ಥರ ಕೇಳ್ತಾ ಇದ್ದಾರೆ ಅಂದರೆ ಈ ಥರದ ಆನ್ಸರ್ಗಳನ್ನ ನಿಮಗೆ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. Next, truth table, they may ask for that one. 0011. ದೇ ಮೇ ನಿಮಗೆ ಯಾವ ರೀತಿಯಾದ ಕ್ವಶನ್ಸ್ಗಳನ್ನು ಕೇಳ್ಬೋದು ಅಂದರೆ ಟ್ರುತ್ ಟೇಬಲ್ಗಳನ್ನು ಕೊಡ್ತಾರೆ. ದಿಸ್ ಇಸ್ ನಾಟ್ ಶೋನ್, ಇದನ್ನು ಕೊಡೋಂಗಿಲ್ಲ. ಕೊಡಲಾರ್ದೆ ಏನು ಕೇಳ್ತಾರೆ, ಇದು ಯಾವ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸು, ಇದು ಯಾವ ರೀತಿಯಾದ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ಬರ್ತದೆ, ಇದನ್ನು ಕೊಡಲ್ಲ. ಹಾಗಂದರೆ ಇದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಯಾವುದು ಅಂತ ಕ್ವಶನ್ಸ್ಗಳನ್ನ ಕೇಳ್ತಾರೆ. ಆವಾಗ ನಿಮಗೆ ಎಕ್ಸೇ ಆನ್ಸರ್ ಬಂದಿರ್ತದೆ. ದಟ್ ಈಸ್ ಆನ್ಸರ್ ಈಸ್ ಎಕ್ಸ್. ಎಕ್ಸನ್ನು ಯಾವ ರೀತಿ ಬರಿಬೋದು, ಅಲ್ಲಿ ಕೊಡ್ತಾರೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್. ಎಕ್ಸ್ ಪ್ಲಸ್ ಎಕ್ಸ್ ಇಂಟು ವೈ, ಎಕ್ಸ್ ಪ್ಲಸ್ ವೈ, ಎಕ್ಸ್ ವೈ ಪ್ಲಸ್ ಎಕ್ಸ್. This is also correct. This is also correct. Then option 1 and 3. Option 1 and 3 is correct. xy plus x is also correct. X will come answer. Right? This is the kind of way they will give for your examinations. X plus x equals to x. X plus x into 1. X plus x into x plus x bar, we have to take that one. In this year you have to see about the multiple choice questions. X plus x equals to x. Why? The x plus x equals to x. X is 0. 0 plus 0 equals to 0. Both are 1. 1 plus 1 equals to 1. Yes? This is the way we have to understand the answers. X into x equals to x. Same. ಹೆಂಗೆ ನೀವು ಅದೇ ಆನ್ಸರ್ ಬರ್ತದಂತ ಎಕ್ಸ್ ಇಂಟು ಎಕ್ಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಕ್ವಶನ್ ಮಾರ್ಕ್, ರೈಟ್? ಎಕ್ಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಕ್ವಶನ್ ಮಾರ್ಕ್. ವಾಟ್ ವಿಲ್ ಯು? ಎಕ್ಸ್ ಈಕ್ವಲ್ಸ್ ಟು 0 ಅಂತ ಹಾಕಬೇಕು. 0 ಇಂಟು 0 0ನೇ ಬಂತು. ಎಕ್ಸ್ ಈಕ್ವಲ್ಸ್ ಟು 1 1 ಇಂಟು 1 1ನೇ ಬಂತು. ಆಯಿತು, ಹಾಗಂದರೆ ಎಕ್ಸೇ ಬರ್ತದೆ ಆನ್ಸರು. ಆನ್ಸರ್ ಎಕ್ಸ್ ಅಂತ ನೀವು ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸ್ ಕ್ವಶನ್ಸ್ನಲ್ಲಿ ಈ ರೀತಿಯಾದ ಆನ್ಸರ್ಗಳನ್ನ ಕೊಡಬೇಕು. ಮೊದಲಿಗೆಲ್ಲ ಹೆಂಗಿತ್ತು, ಎಲ್ ಎಚ್ ಎಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಆರ್ ಎಚ್ ಎಸ್ನ ಪ್ರೂವ್ ಮಾಡೋಕ್ಕೆ ನಿಮಗೆ ಸ್ಟೆಪ್ಸ್ ಇರ್ತಿದ್ವು. ಈ ಸತಿ ಸ್ಟೆಪ್ಸ್ ಇಲ್ಲದೇ ಇರೋದ್ರಿಂದ ಅದರ ಬಗ್ಗೆ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಕೊಡೋದು ನನಗೆ ನೀಡ್ ಇಲ್ಲ ಅಂತ ಅನಿಸಿ ನಾನು ಈ ರೀತಿಯಾದ ನಿಮಗೆ ಆನ್ಸರ್ಸ್ಗಳನ್ನ ಹೇಳ್ತಾಯಿದ್ದೆ. Boolean functions is an expression formed with the binary variables operators or and not, parentheses and the equal signs. The values of the Boolean function can be either 0 or the 1. A Boolean function may be represented as an algebraic expression or a truth table. In the before that one, algebraic expressions, they have given that x plus y bar into z. Which one will be the first? We can take that one, y bar. And next is a y bar into z. Next is a x plus y bar into z. We have to, by stepwise, we have to do that one. First impression, we have to give it into the y bar. Then second preceding, third is a x plus y bar into z. We have to do that one. This is the way to form the algebraic expressions. Yes, this is the way of the truth table. Truth table means we have to represent the LHS equals to RHS ಪ್ರೂವ್ ಮಾಡೋಕ್ಕಂತಲೇ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ಟ್ರುತ್ ಟೇಬಲ್ಗಳನ್ನ ಬಳಸ್ತೀವಿ. ಆದರೆ ಇವಾಗ ಏನು ಬಂದಿದೆ ಅಂದರೆ ಎಕ್ಸ್ ವೈ ಝೆಡ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಡಬ್ಲ್ಯೂ ದೇ ಹ್ಯಾವ್ ಗಿವನ್. ವಾಟ್ ಈಸ್ ದಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್? ಏನಿದೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ನು ಅಂತ ನೀವು ಬರಿಬೇಕು. ಅದು ಹೇಗೆ ಬರಿಬೇಕು ಅನ್ನೋದನ್ನ ಈಗ ಹೇಳ್ಕೊಡ್ತೀನಿ. ಈಗ ಎಕ್ಸ್ 0 ಇದೆ, ವೈ 0 ಇದೆ, ಝೆಡ್ 0 ಇದೆ, 0 ಬಂದಿದೆ. ಯಾವುದೋ ಒಂದು ಝೆಡ್ಡು 1 ಬಂದುಬಿಟ್ಟಿದೆ. ಹಾಗಾಗಿ ಇದೆಲ್ಲನೂ 1 ಬಂದುಬಿಟ್ಟಿದೆ. ಅದೇ ವೈ ಬಾರ್ 1 ಇದ್ದಾಗ ಬಂದಿಲ್ಲ, ಅದು 1 ಬಂದಿಲ್ಲ, 0 ಬಂದಿದೆ. ಇವಾಗ ನಾನು ಥಿಂಕ್ ಮಾಡ್ತೀನಿ, ಎಕ್ಸ್ ಇಂಟು ವೈ ಪ್ಲಸ್ ಝೆಡ್ ಹಾಕಿದರೆ ಬರ್ಬೋದಾ ಅಂತ. ಈಗ ಈ ಫಸ್ಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ನೋಡಿದರೆ ಏನಿಸುತ್ತೆ, ಎಕ್ಸ್ ಪ್ಲಸ್ ವೈ ಪ್ಲಸ್ ಝೆಡ್ ಅನಿಸುತ್ತೆ. ಅದು ಸೆಕೆಂಡ್ ಎಕ್ಸ್ಪ್ರೆಷನಲ್ಲಿ ಏನು ಬಂತು, ಎಕ್ಸ್ ಪ್ಲಸ್ ವೈ ಪ್ಲಸ್ ಝೆಡ್ ಕರೆಕ್ಟ್ ಇದೆ ಸೆಕೆಂಡ್ ಎಕ್ಸ್ಪ್ರೆಷನ್. ಆ ಥರ್ಡಲ್ಲಿ ಏನಾಗಿಬಿಟ್ಟಿದೆ, ಝೀರೋ ಬಂದಿದೆ. ಇಲ್ಲಿ ಒಂದು ಝೀರೋ ಒಂದು ಬಂದರೆ ಇಲ್ಲೆಲ್ಲಾದರೂ ಒಂದು ಬರಬೇಕಲ್ಲ, ಬರಲಿಲ್ಲ. ನನಗೆ ಇದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ತಪ್ಪು. ನನಗೆ ಹಿಂಗೆ ಆಗ್ತಾಯಿದೆ, ಎಕ್ಸ್ ಇಂಟು ವೈ ಝೀರೋ ಆಯಿತು, ಪ್ಲಸ್ ಝೆಡ್ಡು ಝೀರೋ ಇದೆ, ಅದಕ್ಕೆ ಝೀರೋ ಬಂದಿದೆ ಅಂತ ತಿಳ್ಕೊತೀನಿ. ಈಗ ನಾನು ಮೂರನೇ ಸ್ಟೆಪ್ಸ್ ನೋಡಿದೆ, ನಾಲ್ಕನೇ ಸ್ಟೆಪ್ಸ್ ನೋಡಬೇಕಲ್ಲ. ಅದು ನಾಲ್ಕನೇ ಸ್ಟೆಪ್ಸ್ ಏನಂತಂದರೆ ಝೆಡ್ ಝೀರೋ ಪ್ಲಸ್ ಒನ್ ಬರಬೇಕಲ್ಲ, ಬರಲಿಲ್ಲ. ಹಂಗಂದ್ರೆ ಇದು ತಪ್ಪು ಎಕ್ಸ್ಪ್ರೆಷನ್, ಇದು ತಪ್ಪಾಯಿತು. ಮತ್ತು ಯಾವ್ದು ಬರ್ತದೆ, ಹೌದಲ್ಲ, ಯಾವ್ದು ಬರಬೇಕು? ನಾನು ಅವಾಗ ಥಿಂಕ್ ಮಾಡ್ತೀನಿ ಏನಂತ, ಎಕ್ಸ್ ಪ್ಲಸ್ ವೈ ಪ್ಲಸ್ ಝೆಡ್, ಎಕ್ಸ್ ವೈ ಪ್ಲಸ್ ಝೆಡ್ ಅಂತೂ ಬರಲಿಲ್ಲ. ಅಂದರೆ ಆನ್ಸರ್ಸ್ ಯಾವ್ದು ಬರ್ತಾಯಿದೆ, ಡಬ್ಲ್ಯೂ ಯಾವ್ದು ಬರ್ತಾಯಿದೆ ಅಂತ ನಾನು ಥಿಂಕ್ ಮಾಡ್ತೀನಿ. ಈ ಥರದ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ಗಳನ್ನ ನಮ್ಗೆ ಕೇಳ್ತಾರೆ, ಹೌದಾ? ಆವಾಗ ನಾನು ಥಿಂಕ್ ಮಾಡ್ತೀನಿ, ಓಕೆ ಅದು ತಪ್ಪಾಯಿತು. ಇದು ಎಕ್ಸ್ ವೈ ಪ್ಲಸ್ ಝೆಡ್ಡು ಥರ್ಡಿಗೆ ಬಂತು, ಫೋರ್ತಿಗೆ ಬರಲಿಲ್ಲ. ನನಗೆ ಇದು ತಪ್ಪಾಯಿತು ಎಕ್ಸ್ಪ್ರೆಷನ್, ಹೌದಾ? ಆಮೇಲೆ ನಾನು ಏನು ಥಿಂಕ್ ಮಾಡ್ತೀನಿ, ಹೌದಲ್ಲ, ಎಕ್ಸ್ ಪ್ಲಸ್, ಹೌದಾ, ವೈ ಬಾರ್ ಪ್ಲಸ್ ಝೆಡ್ ಬಾರ್ ಬರ್ತದ ನೋಡ್ತೀನಿ. ಝೆಡ್ ಬಾರ್ ಬಂದರೆ ಇಲ್ಲಿ ತಪ್ಪಾಗುತ್ತೆ, ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರೋಂಗಿಲ್ಲ. ಇದು ತಪ್ಪಾಯಿತು, ಹೌದಲ್ಲ, ಇದು ತಪ್ಪಾಯಿತು. ವೈ ಬಾರ್ ಪ್ಲಸ್ ಝೆಡ್ ಬರ್ತದ ಅಂತ, ಹೌದಲ್ಲ? ವೈ ಬಾರ್ ಅಂದರೆ ಝೀರೋ ಆಯಿತು, ಇದು ಝೆಡ್ ಒನ್ ಆಯಿತು, ಇದು ತಪ್ಪಾಗುತ್ತೆ. ಇಲ್ಲಿ ಒನ್ ಬಂದಿಲ್ಲ, ಇದು ತಪ್ಪಾಯಿತು, ಹೌದಲ್ಲ? ಇದು ತಪ್ಪಾಯಿತು. ಇವಾಗ ನಾನು ಇನ್ನೊಂದು ಥಿಂಕ್ ಮಾಡ್ತೀನಿ, ವೈ ಬಾರ್ ಇಂಟು ಝೆಡ್ ಮಾಡಿದರೆ ಬರುತ್ತಾ ಅಂತ ನೋಡಿ. ವೈ ಬಾರ್ ಇಂಟು ಝೆಡ್ ಅದು ಮಾಡಿದರೆ ಏನಾಗುತ್ತೆ ಅಂತಂದರೆ, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಥರ್ಡ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ಒನ್ ಬಂದಿತ್ತು, ಕರೆಕ್ಟ್ ಆಯಿತು. ಎಕ್ಸ್ ಝೀರೋ, ವೈ ಬಾರ್ ಅಂತಂದರೆ ಒನ್ನು, ಇಂಟು ಝೆಡ್ ಏನಾಗುತ್ತೆ, ಒನ್ ಇದೆ, ಥರ್ಡ್. ಈಗ ನಾನು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಏನಂತ ತಗೊಂಡೆ, ಎಕ್ಸ್ ಪ್ಲಸ್ ವೈ ಬಾರ್ ಝೆಡ್ ಅಂತ ಹಾಕ್ಕೊಂಡೆ. ಈಗೇನಾಯ್ತು, ಇದು ವೈ ಬಾರ್ ಝೆಡ್ ಅಂತಂದರೆ ಎಕ್ಸ್ ಝೀರೋ ಪ್ಲಸ್ ವೈ ಬಾರ್ ಝೆಡ್ ಒನ್ ಇಂಟು ಝೀರೋ ಬಂತು. ಫಸ್ಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಕರೆಕ್ಟ್ ಆಯಿತು. ಇನ್ ಸೆಕೆಂಡ್, ಝೀರೋ ಪ್ಲಸ್ ವೈ ಬಾರ್ ಏನಾಗುತ್ತೆ, ಒನ್ ಆಗುತ್ತೆ, ಇಂಟು ಝೆಡ್ ಏನಾಗುತ್ತೆ, ಒನ್ ಆಗುತ್ತೆ, ಒನ್ ಬಂತು, ಎಕ್ಸ್ಪ್ರೆಷನ್ ಕರೆಕ್ಟ್. ಥರ್ಡ್ ಎಕ್ಸ್ಪ್ರೆಷನ್, ಝೀರೋ ಪ್ಲಸ್ ವೈ ಬಾರ್ ಈಸ್ ಝೀರೋ ಇಂಟು ಝೀರೋ ಬಂತು, ಥರ್ಡ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಕರೆಕ್ಟ್. ಈಗ ಫೋರ್ತ್, ಝೀರೋ ಪ್ಲಸ್ ವೈ ಬಾರ್ ಏನಾಗುತ್ತೆ, ಝೀರೋ ಇಂಟು ಒನ್, ಝೀರೋನೇ ಆಯಿತು, ಝೀರೋ ಕರೆಕ್ಟ್, ಹೌದಾ? ಇವಾಗ ಎಕ್ಸ್ ಪ್ಲಸ್ ಅಂತ ತೊಗೊಂಡ್ರೆ ಎಲ್ಲನೂ ಒನ್ ಬರಬೇಕು, ಬಂದಿದೆ, ಇಟ್ ಈಸ್ ಅ ಕರೆಕ್ಟ್. ದಿಸ್ ಈಸ್ ಅ ಎಕ್ಸ್ ಪ್ಲಸ್ ವೈ ಬಾರ್ ಝೆಡ್. ಇದನ್ನು ನೀವು ಕಂಡು ಹಿಡಿಬೇಕಾಗುತ್ತೆ. ಈ ಸತಿ ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸ್ ಕ್ವಶನ್ಸಲ್ಲಿ ಟ್ರುತ್ ಟೇಬಲ್ ಕೊಟ್ಟು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಕೇಳ್ತಾರೆ, ಆವಾಗ ನಿಮ್ಗೆ ಇದೇ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರುತ್ತೆ ಅಂತ. ನಿಮಗೆ 4 ಆಪ್ಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಆ 4 ಆಪ್ಷನಲ್ಲಿ ಒಂದಕ್ಕಾದರೂ ಈ ಥರ ಹಾಕ್ತಾ ಹೋದರೆ ಯು ವಿಲ್ ಗೆಟ್ ದ ಆನ್ಸರ್ ವೆರಿ ಈಸಿಲಿ. The presentation as a truth table as a rows tables equations 2 raised to n, where the n is the number of literal in the functions. The combinations of the zeros and the ones for the rows of this table are obtained from the binary numbers by counting from the 0 to 2 raised to n minus 1. This is a minimization of the Boolean function. Minimization of the Boolean functions deals with the reduction in number of the literals, reduction in number of terms. Minimization is achieved through the manipulating the expression of obtain the equal and the simple expressions having the fewer literal and or the terms are used for that one in the minimization of the Boolean functions. Right. The minimizations of the Boolean functions in your exam in this year the multiple choice questions are there. In this year we have to solve these equations. ಈ ಥರದ ಇಕ್ವೇಷನ್ಸ್ಗಳನ್ನ ಕೊಡ್ತಾರೆ. ಇದನ್ನ ನೀವು ಕಡಿಮೆ ಮಾಡಿದರೆ ಯಾವ ಥರನಾದ ಇಕ್ವೇಷನ್ಸ್ ಬರ್ತದೆ ಅನ್ನೋದನ್ನು ಮಾಡೋದು ನಿಮ್ಮಿರ್ತದೆ. ಯಾವ ರೀತಿಯಾಗಿ ಮಾಡಬೇಕು ಅಂದರೆ ನೀವು ಬಾಡ್ಮಸ್ ರೂಲ್ನ ಅಪ್ಲೈ ಹೆಂಗೆ ಮಾಡ್ತಿರೋ ಕ್ಯಾಲ್ಕುಲೇಷನಲ್ಲಿ ಇಲ್ಲೂ ನೀವು ಕಾಮನ್ಗಳನ್ನ ತೆಗೆದು ಅಸೋಸಿಯೇಟಿವ್ ಲಾ, ಕಾಂಪಿಟೇಟಿವ್ ಲಾ, ಇನ್ವೆನ್ಷನ್ ಲಾ ಇವನ್ನೆಲ್ಲ ಅಪ್ಲೈ ಮಾಡಿಕೊಂಡು ಮಿನಿಮೈಸ್ ಮಾಡಿಕೊಂಡು ಯು ಹ್ಯಾವ್ ಟು ಸಾಲ್ವ್ ದಿಸ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್. ಲೆಟ್ ಅಸ್ ಸಿ ದಟ್ ಒನ್. ಇದರಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ಇದೆ, ಇದೊಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ಇದೆ. ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ನ ಹೆಂಗೆ ಸಾಲ್ವ್ ಮಾಡೋದು ಅಂತ ನೋಡೋಣ. ರೈಟ್. x bar into y bar into z, x bar plus y into z, x plus y bar. It is the there. I am going to take this one. Yes. ಇವಾಗ ನಾನೇನು ತಗೊಳ್ತೀನಿ ಅಂತಂದರೆ ಹೆಂಗೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ನ ಮಿನಿಮೈಸ್ ಮಾಡೋದು. ದೇ ವಿಲ್ ಗಿವ್ ದ ಆಪ್ಷನ್ಸ್ ಫಾರ್ ದಟ್. ಎಕ್ಸ್ ಬಾರ್ ಇಸ್ ಕಾಮನ್ ಆ್ಯಂಡ್ ಅ ಝೆಡ್ ಇಸ್ ಅ ಕಾಮನ್. ಎಕ್ಸ್ ಬಾರ್ ಝೆಡ್ ಇಂಟು ವೈ ಬಾರ್ ಪ್ಲಸ್ ವೈ. ನಾನು ನಿಮಗೆ ಕೇಳ್ತಾ ಇರೋದು ವೈ ಪ್ಲಸ್ ವೈ ಬಾರ್ ಯಾವಾಗಲೂ ಏನಾಗುತ್ತೆ, 0 ಅಂತ ತಗೊಂಡ್ರೆ 1 ವೈ ಬಾರ್ ಇರ್ತದೆ ಇಂಟು ಇಟ್ ಈಸ್ ಅ 0. ಇಟ್ ಈಸ್ ಅ 0. ಕರೆಕ್ಟ್, ಇಟ್ ಈಸ್ ಅ 0. ಅಕಸ್ಮಾತಾಗಿ ಪ್ಲಸ್ ಸೈನ್ ಇದ್ದರೆ ಏನಾಗುತ್ತೆ, ಪ್ಲಸ್ ಸೈನ್ ಇದ್ದರೆ 1 ಅಂತ ಬರ್ತದೆ. ಅಥವಾ ವೈ ಬಾರ್ ವೈ ಈಕ್ವಸ್ ಟು 0 ಇದ್ದರೆ, ವೈ ಈಕ್ವಸ್ ಟು 1 ಇದ್ದರೆ 1 ಪ್ಲಸ್ 0 1 ಅಂತ ಬರ್ತದೆ. ಇಲ್ಲಿ 1. ಎಕ್ಸ್ ಬಾರ್ ಝೆಡ್ ಪ್ಲಸ್ ಎಕ್ಸ್ ವೈ ಬಾರ್ ಈಸ್ ಯೋರ್ ಆನ್ಸರ್. ಏನು ಬರ್ತದೆ ಆನ್ಸರು? ಎಕ್ಸ್ ಬಾರ್ ಝೆಡ್ ಪ್ಲಸ್ ಎಕ್ಸ್ ವೈ ಬಾರ್. ದಿಸ್ ಈಸ್ ಯೋರ್ F2 ಮಿನಿಮೈಸೇಷನ್ ಆಫ್ ದಿಸ್ ಎಕ್ಸ್ಪ್ರೆಷನ್. ಇದು ಮಿನಿಮೈಸ್ ಮಾಡಿ ಬರ್ತಿದ್ದ ಎಕ್ಸ್ಪ್ರೆಷನಲ್ಲಿ ಇದನ್ನು ಬರಿತೀವಿ ನಾವು. ಕ್ಯಾನ್ ವಿ ರೈಟ್ ಇಟ್? ಎಸ್, ದಿಸ್ ಇಸ್ ಅ ವೇ ಟು ಮಿನಿಮೈಸ್ ದ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್. ನಿಮಗೆ ಎಕ್ಸಾಮ್ನಲ್ಲಿ ಕೊಡ್ತಾರೆ ಯಾವ್ದು ಕರೆಕ್ಟ್ ಇದೆ, ಎಕ್ಸ್ ವೈ ಬಾರ ಎಕ್ಸ್ ಬಾರ ಅಂತ ಕೇಳ್ತಾರೆ. ದೇ ವಿಲ್ ಆಸ್ಕ್ ಫಾರ್ ದಟ್. ಆವಾಗ ಏನು ಹೇಳ್ತೀರಾ? ಎಕ್ಸ್ ಬಾರ್ ಝೆಡ್ ಕಾಮನ್ ತೆಗೆದ್ವಿ, ಎಕ್ಸ್ ಬಾರ್ ಝೆಡ್ ಎಕ್ಸ್ ಇಂಟು ವೈ ಬಾರ್. ದಿಸ್ ಇಸ್ ಅ F2. ದಿಸ್ ಇಸ್ ಅ ಮಿನಿಮೈಸೇಷನ್ ಆಫ್ ದ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಆಫ್ ದ Boolean expression. Minimization of the Boolean expression. This is a truth table. But in this year truth table is not necessary. ಇಲ್ಲೂ ಕೊಡ್ತಾರೆ. ಯಾವ ಥರನಾಗಿ ಕೊಟ್ಟಿದ್ದಾರೆ? ಎಕ್ಸ್ ಪ್ಲಸ್ ಎಕ್ಸ್ ಬಾರ್ ಇಂಟು ವೈ. ಯಾವುದು ಕಾಮನ್ ಬರೋಂಗಿಲ್ಲ. ಅಲ್ಲಿ ನಾವೇನಂತ ತಗೋಬೋದು? ಎಕ್ಸ್ ಇಂಟು ಎಕ್ಸ್ ಬಾರ್ ಪ್ಲಸ್ ವೈ. ಈ ಥರನಾದ ಇಕ್ವೇಷನ್ಗಳನ್ನು ಮಿನಿಮೈಸೇಷನ್ ಮಾಡೋದನ್ನು ಕಲಿಬೇಕು. ಟ್ರೈ ಔಟ್ ಸಮ್ ಬೂಲಿಯನ್ ಫಂಕ್ಷನ್ಸ್ ಮಿನಿಮೈಸೇಷನ್ಸ್ನ ನೀವು ಎಕ್ಸಾಂಪಲ್ಗಳನ್ನ ಟ್ರೈ ಮಾಡಿ ಮನೆಯಲ್ಲಿ. ಇದು ಬರಲಿಲ್ಲ ಅಂತಂದರೆ ಐ ವಿಲ್ ಡೂ ಇಟ್ ಆ್ಯಂಡ್ ಸೆಂಡ್ ಇಟ್ ಬ್ಯಾಕ್. ದಿಸ್ ಇಸ್ ಅ ಹೋಮ್ವರ್ಕ್ ಫಾರ್ ಯುವರ್ ಫಂಕ್ಷನ್ಸ್. ಇಫ್ ಯು ಆರ್ ಟ್ರೈ ಇಟ್ ಇನ್ ಯುವರ್ ಹೋಮ್, ಇಫ್ ಯು ವಿಲ್ ನಾಟ್ ಗೆಟ್ ಇಟ್, I will solve it. Okay. Thank you. Please watch our videos regularly. Then if you have any queries, ask us. Okay. This is the homework for you. You have to try out. If you will not get it, I will solve it. Okay. What is the equations will come? You will send the answer to me and I will give the answer. Okay. Okay. Thank you. Please watch our videos regularly.